thank you for being here. And let me just share my screen and then we will get it going. All right. So now, first, we want to kind of give you a brief overview of what we'll talk about today. So basically, I will really briefly talk about what is computer science and why it is important. And then we will get into problem solving and algorithms. We'll get into more about this and then you know what those actually mean. Okay, so now first, what and why. Okay. Now, what is computer science? It is basically a study of computer system, how computer works, right? And there are many different areas in computer science, right? Areas something like graphics, human computer interactions, networking, databases, AI, right? So that many different areas. And why it is important? It is important because it is really all around us. Okay, you can see computer science hidden in everyday things around us. Okay, so if you look around you, all right, and do you see anything that has computer science actually hidden in it? If you see something like this, if you think of anything, let me know. Anyone? No? That's okay. Let me show you some of the things that around us that's really common, and computer science take an important part of how those things works. Okay, so something like fridge, okay, thermostat, your TV, robot vacuum, game console, smartwatch, cell phone, car. These are the kind of things, and many other things as well, right? That has computer science in it. All right. So if you think about it, just take the TV as an example. All right. What's are involved in TV? Well, think about all the pixels you see on your screen, right? Those have graphics involved. All right. You need to get all those signals from somewhere. There's networking. Okay. There's a menu. You need to learn how to use the menu and then navigate through it. There's human computer interaction side of things in there. And then there's AI, maybe it gives you some suggestions of what you want to see or not. And then there's like maybe databases to sort of store your personal information in the system. So that many aspects of computer science are actually hidden in everyday things. All right. Now, let's look at let's look at how how all those things are actually also in common. Well, there is obviously computer science involved, but they have some purposes. All right. The purpose they have, which like they help us to do something, right? There are something that we want to do. There's some challenges, there's some problems we want to solve. And these things help us solve those problems. All right. Now, in computer science, we often need to look at some problems and we figure out how to get to the solutions. Okay. And
Nelson, I think
there
we
are,
just have a question in the chat. Sorry, don't want to
oh, oh,
catch
yeah,
you
yeah.
off there. It's just
Yes.
asking, isn't computer science only things that have a CPU?
Is it, I'm sorry, can you say it one more time, please?
Yeah, it's just the question is, isn't computer science only the things that have a CPU?
No, not really. of course, there's the CPU, there's computer science, but then computer science can also involve things like, um, give you an example, like how, like designing some interfaces, right? Let's say remote control, okay, to control a TV, okay? How the remote control are actually designed well so that you can actually uh, use your TV uh, easily, right? And so these are the things that involve human being studying how we interact with not just things that with CPU, but also have hardware involved. So it is more than just something that has a CPU in it. All right. Okay. So let's get going. Okay. Continue on. So now we want to solve some problems, okay, and get to some solutions. And there are many, many steps involved, all right? And um, to go from some kind of challenges, some kind of problem, to writing some kind of programs, and then having the programs and design some hardware and combine them together, and then that help us do things, okay? And so really the heart of computer science is about problem solving. It's about how to we um, solve some problems to help us do things. Now, give you some examples. Okay, something really simple. I want to make a cup of coffee. How do we do it? All right. So, is there any coffee drinker here? You have like, how do you make coffee? You have one one way to do it, or your favorite way to make coffee? Anyone?
I would say mine personally is probably using a coffee pot. Easiest
Yeah,
one.
yes, coffee pot, right? Using coffee pot. Now, I'm assuming you coffee pot, you like, turn on like a coffee machine, right? Open it up, put a coffee pot in, close it, turn it like start, and then, put a cup there and it's get going, right? So, so that's one way to do it. Now, the way to describe it, there are many ways that we can describe how to do something, okay? Now, what you see over here something we call algorithms. Okay, and one way to express algorithm is to through text, just step by step instructions to um, clearly describe how to do something. All right, and this is actually quite useful because it's hard to make mistake if the steps are clear. Okay, and if we follow the step, we can solve the problem. Okay, and right now the problem is, oh, how to make a coffee, right? And so I'm going to show you something that I'm sure some of you have seen. They are around us, and you try them probably, and just different ways to express algorithms. Okay. Okay. Now we have another problem to build some furniture. How do we build a desk, right? Well, follow some diagrams, okay? Step by step instructions. This is another way to show algorithms, okay? To represent ways to do something, to solve some problems, all right? And other things, right? Legos. We want to build some Legos. How do we do it? Well, we look at the instruction booklet, and they are in some clear forms, but then generally not text heavy, right? Diagrams, graphics, again, step by step, clear instructions. If you follow them through and the instructions clear, you can solve the problem. All right. And this is another kind of algorithm. Okay. And there are other algorithms. So let's say I want to decide whether I should eat a piece of pie. All right. And we can have some algorithms to help us decide whether I should eat the pie. So something like this, right? Well, see whether it's go over the calorie goal. If it is, well, don't eat it. If it is not, well, maybe it is okay to eat, and then see whether it is yes or no, and then we make the decision based on some algorithms. All right. And then we can decide what to do. Again, there is a problem and there is an algorithm. And if we follow through, we can solve the problem. All right. Now, this is another example. I'll show you some other ways to express algorithm. Okay. So think about this. All right. Let's say you want to buy something from a local convenience store. All right. And it only accepts cash. And you buy something and they, oh, let's say something is like, I don't know, something like 450 and you have $10 bill. All right. So you give the cashier $10 bill and the cashier need to give you changes. Okay. And the idea is that, well, we need to know how to give change, right? And we want to, let's say, give the least number of coins as possible. We don't want to give like 1,000 pennies, right? Something like that, right? So let's say if it is uh, 450 and then you need to give change, which is 550, all right? And the ideal case, in this case, in terms of coins, not bills, would be 2 tunis, 1 loonie, and then 2 quarters, right? And that would give you 550 back. So that's what we want, not like, you know, 5 loonies and then um, 5 times, right? So we want to have at least give back least the least number of coins as possible. Now, how do we do it? Well, we can express the algorithm using something like this, a flowchart. Okay. So how to do it? Well, we want to know how much the change is. Okay. If the change that we need to give back is more than $2 or more than or equals to $2, then we give a 20 back to the customer. And then we go back and then we ask the same question and see, okay, is the change still bigger than $2 or equal to $2? If it is still more than two or equal to $2, we give another 20 back. Until it is no, then we move on and we ask the same question, but with different values. Is it greater than or equals to $1? If it is, we give back 1 loonie. Okay. And then we continue on until it is not greater than or equal to $1. And then we move on to quarters. And then we continue on this process until we give away the right amount to the customer, right? So this is another way to express algorithm and in the form of flowchart, all right? Now, the same algorithm can be expressed using simply just text, okay? So this is the same algorithm as this, all right? But just in the form of text. So while the change is greater than or equals to 2, I give a tuning. And then we go back and check whether, okay, is it still greater than or equal to 2? If it is, it give another tuning. And we keep on doing that until this is no longer true, okay? Unless the change is less than $2, then we give $1 loonie, and then we continue on. So the idea is the same as this, but it's just showing in different ways, okay? One in terms of flowchart, another one in terms of text, right? Now, we want to see whether we can actually convert this to some kind of program. Now, to make it easier to explain, I will simplify this example, okay? And we will basically only assume we have loonies, loonies, and quarters, and that's all we have, all right? And Now, this is what we have. So if we actually are going to do something, write the program to do this, okay? There's something that we actually need to keep track of, right? We need to keep track of how much change is left. And we also need to keep track of number of tunies, number of noonies, number of quarters we need to give back, right? We need to somehow remember this, right? Now, so this, we will need to get into a little bit more details. And we call this kind of a little bit more details algorithm pseudocode. It is kind of like code, but not exactly. It is still in text form, but it is detailed enough that we can eventually translate pseudocode to any kind of programming languages we want. Okay, so to do that, we first simply need to get the input, okay, to see what change we need to give back to the customer, right? So that's step number one. And then we also need to start keeping track of number of tunies, noonies, and quarters that we need to give back, right? At the beginning, we are not giving anything yet, right? So they're all zeros. And then we get into this part, okay? So while the change that we're keeping track of is greater than or equals to 2, what do? We will need to give one toonie back, right? And this is how we keep track of number of toonies we give back. We increment the number of toonie by 1. And we give 1 back, but we need to also decrement change because we give a toonie back, change need to decrement by 2. All right. So we need to decrease the change by 2. And we keep on doing this just like this flowchart. So this is the pseudocode version of this algorithm. All right. And we will repeat this, keep on doing this until change is no longer greater than or equals to 2. Then we move on to noonies, right? So we do the same thing for noonies, okay? And we keep track of noonies, but make sure that the change is greater than or equals to 1. And we decrement change by 1, not 2, because noonies is $1. All right. And we keep on doing this until the change is less than $1. Then we get to quarters. Okay. And again, we keep track of number of quarters we need to give back. And we decrease the value of change by 0.25. All right. And we keep on doing this until it is done. And at the end, we want to show the number of toonies, noonies, and quarters we are giving back. All right. So this is pseudocode. All right. Once again, this is the same algorithm as was is on the left with more details. And it is detailed enough that we can translate this to any kind of programming languages. All right. Now, let's look at some examples. All right. So if we convert this to a programming language, and this is Python, okay? And it looks something like this. It is, in this case, basically kind of like one-to-one conversion, all right? And obviously, if you don't understand what this actually means, that's okay. That's not important at this point, right? The idea is that we can use pseudocode, which is one way to show algorithm, okay? To convert this to any kind of programming language we want. So this is one example. And this is another example. This is JavaScript. And it's no different, right? But we can just translate it. And this is another one. Okay? This is Java. All right. And again, using the same pseudocode, the same algorithm, we can convert that to some programming languages. All right. And once we have this kind of programming languages, we can then run it in the platform that we choose, or we can combine this kind of code with hardware to help us solve problems. All right. Now, one thing I want to point out is that programming or coding is not all of computer science. Okay, this is some common misconception that, oh, computer science is really all about coding. It is not. All right. Programming or coding is simply a tool. It is one of many different tools that help us solve problems. All right. We use programs, and then we can combine it with hardware. We can combine it with design of the interface, design of the hardware, and then maybe uh, put everything together. Then we can solve the problem. All right. And so just keep this in mind. Programming is a tool to help us solve problems. All right. And the heart of computer science is about problem solving. There is something that we want to do. There's some problem we want to solve. There's some challenges we want to overcome. We figure out how to do it by writing, designing algorithms, and then we convert those algorithms to code, and then we combine some code with other things to make something that can help us solve the original problem. And that would be my lecture. Is there any questions for me?
Yes, if you have any questions, feel free to utilize that Q&A box or the webinar chat. I'm just gonna hop on really quickly and do my quick presentation for you guys, which if you have come to the sample lectures before, you're probably familiar with. But you can see here, we just have a little thing about starting your journey with the University of Calgary. So we just watched an amazing sample lecture on computer science. And if you're interested in joining the computer science program, this is kind of your way to get into it. So you can see here, these are just a couple of things about the University of Calgary. So University of Calgary at a glance, just some quick statistics. We were founded in 1966. We have about 28,000 undergraduate students, 5 campuses, and 14 faculties, which is quite a bit to do in less than 100 years. We also are Canada's entrepreneurial university. We have about $504 million in sponsored research funding. And then these last two are my favorite statistics of all, a 94% after graduation employment rate and a 95% undergraduate retention rate. And that undergraduate retention rate, as a student myself, it can speak that it is very, very accurate, but it speaks to the student life satisfaction on campus, with classes, with professors, with just every kind of service that you can get through the University of Calgary. It keeps students around and it keeps them wanting to come back for another year. So this is just a little bit about our admissions information here. So the basis of our admissions is that we're looking at 5 faculty-specific classes that are going to be competitive in nature. So it's going to be a competitive admissions average based on those 5 classes. There are some additional programs that have some supplementary application pieces. So for example, health sciences has a little bit of a written piece that you would have to do. Fine arts, dance, and music has an audition, and then visual studies has a portfolio. So those would be the programs that have additional pieces to it. And then this is just a little bit about getting into the computer science program in particular. So we're looking at English. That's kind of constant across all of our programs. Alberta Mathematics 30-1 or equivalent. So if you're out of province or out of country, we're just looking for a pre-calculus equivalent class to cover that Alberta Mathematics 30-1. 2 of biology, calculus, chemistry, physics, or computer science. So you get to choose 2 of those guys to include in that admissions average, and then an approved course or option. And that approved course or option could be your social studies classes, it could be additional science classes, it could be physical education. There's a bunch of different options for those approved courses or options. And then for the overall admissions average, we're looking in the high 80s for that competitive average. So those 5 classes are going to be, competitive when you reach that high 80s mark. And then these are just some important dates. So again, if you're joining us and you have an offer for fall 2024, you are familiar with this chart, hopefully. But the upcoming one is that May 1st decision deadline. So if you haven't decided yet and you haven't accepted that offer, make sure to do that before May 1st. And then for any of our students joining us who maybe are thinking about applying for fall 2025, this is going to be your kind of chart. So the big dates to think of are August 1st for international students is when the application opens, October 1st for domestic students, and then March 1st is when that application closes. So good to keep in mind as we go throughout the year. This one's just good to have on hand. We do have this on our website as well. And if you'd like to connect with us, you can connect with your region-specific recruiter on the left-hand side QR code here. So we have region-specific recruiters for all across the world. So you can get in contact with somebody who knows your curriculum, knows your area a little bit more. We also have the option to download our view book just in the center QR code, and then all of the different ways to connect with us here on the right-hand side of the screen. So we have the future students email. If you're not sure who to email, just email that one, and we'll get you where you need to go. We also have our Facebook account, our Instagram account, Pinterest, and then our podcast. So if you like listening to me talk, you can tune into season 8 there. We have on professors, we have on students, a bunch of really cool things there. And then if you'd like to rewatch this sample lecture today, you can go to the Choose UCalgary YouTube account because all of the sample lectures are being recorded and will be put on those YouTube accounts. So you can go and revisit them there, or if you missed any of the previous ones, you can find them all there. So that's all I have for you guys today. I'm just going to open up the floor to questions. If you have any admissions related questions, I'll just be answering them in the chat. And then if you have any questions for Nelson, please feel free to start up that conversation in the chat or Q&A function, or you can also raise your hand and speak out loud if you're comfortable. We have a raised hand here, or I missed it. Did anybody raise their hand? Thank you, Ryan. I'm just going to check on our Facebook here to see if we have any questions in the live stream chat. I mean, I've got to say, Nelson, I didn't know a whole lot about computer science before this, but this has definitely taught me a lot more and kind of made it a little bit more approachable, I would say, from an outsider's perspective looking in. Definitely a very interesting concept and a very, very interesting way to kind of like lay it out with those like toonies and the change idea. It really helped me kind of understand a little bit more on what coding really is.
Yeah, that's great.
So I think if we don't have, oh, you have one question. Oh, just transfer questions. I'll answer that for you here. Perfect. I'll do one final call out for questions here. If anybody has anything, or if you think of something after the fact, you can also send us an email. And I can send it over to Nelson or find an answer for you myself. This lecture was very educative and fun. I really enjoyed it. Thank you so much.
Thank you.
Perfect. So I think got all my questions answered in the chat there. So I think we'll end it for today, but thank you so much for coming out, and thank you so much, Nelson, for coming on. That was amazing. I really learned quite a bit, and I'm sure everybody else learned quite a bit as well.
Thank you so much for inviting me here.
Thank
It's a
you.
pleasure. Thank you.
Thank you so much.